Okay, so hopefully you're done with 10.4 notes, and we're just going to finish lesson with 10.5. There's just one thing from 10.5 that we're going to cover, which is circumscribed angles. So we talked about inscribed angles, which were angles that were on the vertex of a circle. Okay, so these were inscribed angles. Okay, now circumscribed angles. This is an angle. So an angle whose sides are tangent to a circle. So just an angle with sides tangent to the circle. And we learned what tangent was a while back, but you see that here we have B. Now the sides of this angle right here, or angle B, see that this side right here is tangent to the circle, as well as this side right here. This side is also tangent. Now what we did learn a while back is that this case right here, we learned that the sides are actually congruent. So the distance from A to C is the same as the distance from B to C. So we did learn that. Okay. So now we're going to apply a different theorem to this type of situation right here. So we know what a circumscribed angle is. It's an angle whose sides are tangent to a circle. Now the theorem states that the measure of a circumscribed angle, so the measure of a circumscribed angle is equal to 180 degrees minus the measure so it's equal to 180 degrees minus the measure of the central angle that intercepts the same arc. Okay, the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. Okay, so you see that we'll have a center, right, of a circle. Now we have what we call here the circumscribed angle, angle B, and you see that it intercepts its tangent, which means it does have to intercept the circle at exactly one point. Now these intercepts A and C form a central angle. Okay, and right here you can see this theorem basically just says that if you have a circumscribed angle, so circumscribed angle with the sides are tangent to the circle, now you see that they intercept at points A and B, okay, and these it forms the central angle right here. Now the central angle and this angle, basically these are supplementary, right? So if I use this formula right here, so measure of angle ADB, which is this angle right here, and measure of angle ACB, which is the central angle. Okay, so this angle is equal to 180, so this angle is equal to 180, subtract this angle right here. But then you could also say, then in this case I could add measure of angle ACB. So then 180 degrees would have to be equal to measure of angle ADB plus measure of angle ACB, and this by definition is supplementary. They have to be supplementary. Okay, so let's apply this theorem here. So find the value of x. So we have the circumscribed angle right here. We know it's circumscribed because you can see that it's tangent. The sides are tangent to the circle and intercepts at point A and B. And then we have the central angle, which intercept at the same arc, at 135. So remember that the definition states that 180 has to be equal to, or sorry, no. Let me make sure I'm looking at this. So the measure of the inscribed or circumscribed angle, so measure of angle ADC. Now, I'm just going to say x because that is x. So I'm just going to say x, I guess. So x has to be equal to 180 minus the central angle, in this case, which is 135. So x has to be equal to 45 degrees in this case. Okay, now B might be a little bit more tricky. We have to use some theorems from the previous chapter in 10.4. Okay, so first of all, this theorem, we need to have the circumscribed angle and we need to have the central angle. But notice that in this problem here, we don't have the central angle, we have a inscribed angle. Now, what do we know about inscribed angles? What we know about inscribed angles is that they are half the measure of its intercepted arc. So you see that this has an intercepted arc right here, like that. Okay? So keep that in mind. Okay? Now I know that, I know that this angle right here is 30. So this measure right here is going to be half of whatever this measure right here, but we also know that measures of arcs are the same as the measure of the central angle. So measure of EF has to be 2 times the measure of x. So this has to be 2x right there, right? And then this measure right here would also have to be 2x. So the central angle would have to be equal to 2x because it's the same as that right there. Okay, so this has to be equal to 2x. Okay, now that I know that, let's use this theorem right here. So I know that the circumscribed angle, which is 30 degrees, so 30 has to be equal to 180 minus ACB, so the central angle, and I know the central angle is 2x, right? Okay, so I know that that is 2x. Now I'm going to move items around in order to solve for x. So I'm going to add 2x, and I'm going to subtract 30 to both sides. So add 2x, subtract 30 to both sides. So on the left side, the positive 30 and the negative 30 go away, and I'll be left with 2x. So I'll have 2x is equal to 180 minus 30. Now 180 minus 30 is equal to 150, and then I could divide both sides by 2, and I get x is equal to 75. Okay. Alright. So that should pretty much do it. That's all we need to do. So here's some example problems that that you guys can do on your own just to get the practice in. So again, I think the harder ones are with these ones right here. Just remember that this measure right here is equal to double of this angle right here, so that angle is x. But we also know that this angle, this arc, is equal to the central angle. So this angle has to be 2x, and that should help you use the equation from the theorem that we just learned. Okay. Alright, and that should pretty much do it for 10.4 and 10.5.